The molecular classification of central nervous system tumors has undergone a profound transformation in the last decade, driven by the integration of genomic, transcriptomic, and epigenetic technologies into diagnostic practice. This shift has allowed us to move beyond the limitations of purely histological classification, incorporating key molecular alterations that define entities with precise prognostic and therapeutic implications. Consequently, current neuropathological diagnosis demands an integrated approach that combines morphology, molecular biology, clinical context, and radiological findings, especially in childhood malignancies. Among the most relevant advances is the characterization of histone H3 mutations, particularly the K27M alteration in diffuse midline gliomas, the identification of which has diagnostic and prognostic value. However, the detection of this mutation in distinct circumscribed tumors has necessitated a more nuanced interpretation, establishing that it does not in itself constitute a criterion for malignancy, but rather must be assessed within the corresponding anatomical and biological context. Taken together, the ongoing identification of new molecular entities highlights the biological complexity underlying CNS tumors and confirms that genetic and epigenetic information is now an essential component of diagnosis and clinical stratification. Ultimately, this dynamic landscape demands regular updates to classification systems and reinforces the need for an integrated, rigorous, and contextualized interpretation.